This video will show you how to test for one population proportion using binomial test. If in a study a random sample of 500 high school students was surveyed and 232 of them responded that they did not wash their hands before lunch at school, and we want to use this data to help us to test at 5% level significant and to see if more than 40% of the students in this sample population who did not wash their hands before lunch at school. So for this problem we can set up the hypothesis for the test, and the null hypothesis will be the proportion of students who did not wash their hands as 40% or 0.4, and the alternative will be the proportion of students who did not wash their hands is greater than 40% or greater than 0.4. To do the analysis, first I have to create the data. Now we have students who did not wash their hands, and let's use 1 to indicate that case. And for students who did wash their hands, I use 0 for indicating that. So I actually use the indicator variable, 1 indicating did not wash their hand, the category of interest, and 0 student who did wash their hands. And of course we're not going to generate 500 cases. We're going to use weight cases by option to weight these two cases based on the frequencies that we have. So we actually have 232 cases of 1s. So right next to 1 we're going to type in 232. Of course the remaining is 268 cases. I'm going to type that 268 right next to 0. So I create a variable that's really the frequency of 1s and 0. Who did not wash their hands and who did wash their hands. I'm going to name this variable 2 as frequency, and I'm going to name the first variable hand wash so I know which variable is which. Then I'm going to use weight case option in SPSS. I'm going to click data, weight cases, and I'm going to check on weight cases by and select the frequency as the weight. So click it in. This is frequency variable, and I click OK. So after I've done that, SPS is going to from now on consider this data file has 232 cases of 1 and 268 cases of 0s. So you don't have to type 500 cases. So this is the way you create data when your data has been organized and you have the frequency information. And to run the binomial test for one population proportion, we click on Analyze, Non-Parametric Test, and let's select Legacy Dialog and click on Binomial Test. I'm going to check hand wash variable and put it as a test variable. And remember the null hypothesis is 40%. We want to test whether the proportion is greater than 40% or not. So the test proportion should be 0.4. After you've done that, you click OK. SPSS will generate the output for us, and this is the result from the binomial test. We have 232 cases of 1, 268 cases of 0. 1 again is those students who did not wash their hands. The observed proportion, of course, for did not wash their hands should be 0.464, but SPSS actually rounded up to 1 decimal place. That's why you see 0.5, but actual proportion is 0.464. If you double click on 0.5 for group 1, category 1, you find out the actual number, which is 0.464. And this indicating that the proportion is greater than 0.4, so your evidence actually is supporting the alternative hypothesis you have more than 40% of the students who did not wash their hands before lunch. And the column right next to it, exact sig 1 tell, this is the p-value for the test. 0.002 is less than 5%, 0.05, So we're going to reject the null hypothesis and support the alternative that the actual proportion is greater than 0.4. If you wish to do two-sided test, then the p-value will be twice of this. That will be 0.004. Now, if you see an observed proportion that is not greater than 0.4, as you indicated in your alternative hypothesis, then your evidence is not supporting the alternative hypothesis. Since your evidence is not supporting the alternative hypothesis when you're doing one-sided test, in fact the p-value will be whatever p-value show here, subtracting from 1. And if you're doing two-sided tests, you will multiply this number by 2 to get the p-value.